Hey, I'm Dr. T and welcome to my office. So today I would like to talk a little bit more about molecules. When we talk about molecules, we actually have more information to describe than simply their molecular formula or the number of each atom within our molecule. Quite often we want to discuss not only how many of each atom we have, but also the way that they are configured, because you can have two molecules, what we call isomers, that have the same atoms, just arranged differently, and are therefore different molecules with completely different properties. To do this, quite often we use what's known as a Lewis structure. Lewis structures takes the symbols for the atoms, draws them out two-dimensionally, showing the shared electrons by lines. So if I was to have the Lewis structure for, say, methane, then I would have a carbon, and it would have a line to a hydrogen. The carbon would have another line to another hydrogen, and repeat twice more, thus indicating that there are 4 hydrogens attached to that one carbon. And it's not that, say, the hydrogens are attached to each other, because that's not how it works. Now, with this one, I can, kick this up a notch, or I can go to other compounds that get a little bit more interesting. For instance, something like formaldehyde. I have a carbon, it's got a bond to a hydrogen, it's got a bond to another hydrogen, and it has a bond to an oxygen, but that bond to the oxygen is what we call a double bond, and there are 4 electrons. So instead of using a single line, I'm going to use a double line. Also, I can point out that that oxygen has valence electrons that aren't actually in a bond, what we call lone pairs, and so I can put those on sides of my oxygen. This gives me a lot of information about what my molecule is doing and how it's connected. This can also start giving me some interesting information about what it's going to do and behave like. Now, covalent bonds are not necessarily an even sharing, and in some cases certain molecules will have some of their atoms sharing the electrons more equally than others, in the words of George Orwell. These are what we call polar bonds. Essentially, one of the atoms is hogging the electrons from the other one. While the entire molecule doesn't have a charge, because the sum total of all electrons and protons cancels each other out, certain parts of that molecule could have a slight positive or a slight negative charge, what we call polarity. Because of this, these molecules tend to stick together. This sticking together is what we call a dipole-dipole interaction, otherwise known as a type of intermolecular force. The types of intermolecular forces individual molecules can do tells us a lot about how they will behave with each other. Not all molecules are capable of doing dipole-dipole interactions, and some of them are capable of doing quite a few, where others, just 1 or 2. And once again, some, none. The key features of these intermolecular forces, the stronger the force, the more likely it's going to be difficult to break it apart into a liquid. It's going to stick together more so. Therefore, its melting and boiling points typically are going to be higher. And it's going to typically like to interact with other molecules that utilize similar intermolecular forces. We can see this with sugar. Sugar has a lot of very polar bonds. That means that if you wish to melt sugar, good old sucrose melts at that temperature that I'm going to go look up, which is ridiculously hot. But it does like interacting with water, since the types of intermolecular forces within sucrose are similar to those within water, except for it happens to have more of them, therefore it stays a solid until a much higher temperature. If you look at something like an oil, its intermolecular forces are weaker. It doesn't have that aforementioned polarity. Its melting point, while still higher than that of water's, is surprisingly low for a molecule that size. Additionally, because it doesn't have the same intermolecular forces as water, the two don't mix. Oil and water are legendary for not mixing well together. So with that said, have a wonderful day.